Welcome to the probability class. Conditional probability. Under conditional probability, we'll talk about the axioms of probability or the properties of probability, and we'll look at a few examples of how probability can be applied. To begin with, probability is defined as the likelihood of an event occurring on a daily basis. Probability or chance characterizes the order of the day. Examples may indicate the chances that an accident during Christmas will occur, the baby will be a boy or a girl, the weather, it will rain or not, or infections of COVID. These are an utter chance or probability of life. So you need to understand the axioms of probability. So we have about 13 axioms of probability. To start with, probability should range between 0 and 1. This means we can never get anything more than 1 and anything that is negative when we're dealing with probability. Then we have what is called the additives of probability, the additions. So when we're adding set A and set B, we're uniting them. So that is called the union set. So if we add A and B and it's giving us 100%, union set. So for disjoint sets, they look like this. So if set A and set B are added, we're uniting them. So this is set A and this is set B. So A union B is equal to 1 when you're dealing with disjoint sets. So meaning this is 40%, the other one, the percent. But if there's an intersection, it means there's something in common. The meeting point is called an intersection. So where A and B are meeting, that is called A intersection B. Now in this instance, the union set formula will change. Instead of A and B, when you add them, giving you the union, we're going to subtract the intersection here because it will be repeated. So now our A union B becomes what? The probability of A plus the probability of B, subtract the intersection. So this is how the union set formula can be done. Are we together so far?
Hello.
We're together so far?
Answer.
All right.
I think so.
So these are the axioms of probability. So today I'll just dominate on 7 axioms of probability. Then we'll look at an example. Then we'll look at part of the assignment by yourselves. So ideally, these assignments, you must be able to answer them through the class tutorials by the doc, or additional tutorials that we are having here. So we are on axiom number 2. The union set of A and B is probability of A. Probability of B is subtract the intersection of A and B. The complement means what is outside. So the probability of A is equal to 1 minus probability of A. The complement of A means what is outside A. So A If A is 20%, the complement of A is 80%. The probability of A given B, we take B down there, then we're going to intersect A intersection B on top there. If we have B given A will come down there, then we're going to intersect A intersection B. This is a most important part of conditional probability because you're getting to understand the pattern. Will you tell me, how do we expand the probability of A given B? Just from explaining. The probability which will go down is the bottom one. The B will go down here. Then on top, we're going to intersect A and B, because those are the prevailing letters. Of course, sometimes we want to start with the alphabet which comes, alphabetical letter which comes first. So here we're going to have probability of what? A intersection B. Right. So can somebody try? Suppose we're upside down here. We have B given A. B given A. How do we expand this?
I think they need to be the probability of P downward of A.
Then on top,
We have B intersection. Oh, A.
the same thing, B intersection A or A intersection B. That's okay.
Okay.
That is called A theory. So when you cross multiply this one and that one, you get the intersection there. So the probability of A given B, you multiply it by what? By the base itself, by B. What we get? The intersection of A intersection B. So how about if we expand it there? How do we get the intersection of A and B on the other side? When we multiply what? B given A times A, we get the intersection of A intersection B. As long as this one, the base is the same as what you're multiplying, you get an intersection. So if I have to multiply probability of X, what do I multiply it by? In terms of Y, to get the intersection, I multiply by Y given what? X. This slash is called given. It must be down. This must be down, and that one must be the multiplicand. So this one will give us the intersection between the two letters of A and B. In this case, we're dealing with the X and Y. All right. So I want somebody to try. If we have probability of A complement. How do you find the probability of A complement? It is 1 minus what? A itself. So if A is 20%, what is the complement of A? A is 20%, what is the complement of A?
80%.
80%, correct. So this is how the axioms of probability are. So we also have what is called Theorem Two. If you have probability of A, it is A intersection B, but the complement will be on the other letter. So if there's A there, the complement is beyond B. If there's B there, the complement will be on A. Ideally, we're taking the letter which is common. What letter is common between these two? It is A. So here we're going to have A. Here, what letter is common? It is not A because this one has a complement. We have B here and B there. So this is what we call theorem 2. So if we had the probability of A intersection D plus B intersection D, the total will be what? The probability of the common letter. So what is the total going to be? If we're going to add A intersection D plus B intersection D, what are we going to get? The probability of what? The letter D. So you pick the common letter. In short, this is called theorem 2. Any questions so far before I proceed? Any questions before I proceed? All right. So we're going to look at
Hello?
a mini
Hello?
example. So based on just these three that I've talked about here, before we talk about the other one, but question number 1 into question number 2. So a given probability of A is 0.3, probability of A given B is 0.5, and probability of B is 0.4. The solutions. So we are being asked to find the intersection of A and B. So we're given A 0.3, B 0.4, and A given B 0.5. So the first thing, you need to expand A given B. We say B alaya panchi, then you're going to intersect A and B like that. We agree on this here. This is what we started from. So where there is A given B, we have 0.5 there. We'll put it here. Where there is probability of B, there is 0.4. We'll put it here. Then we are looking for A intersection B. We cross multiply. 1 times the intersection into the intersection there. 0.4 times 0.5 gets 0.20. So this is how we find the intersection of A and B using Bayes' theorem. So if you mess up, you put an A there instead of a B, your answer will be wrong. So then how do you find the union set? A union B, we're going to have A plus B minus intersection. So the answer that we're from getting here. So where there is A, we're already given A as 0.3 and B is 0.4. So here you put 0.3 and here 0.4, then minus the intersection of A and B is 0.2. So we add this plus that minus that, we get 0.5. So this is how we find union set. Then 1 minus the probability of A, we get the complement. So since our A was 0.3, 1 minus 0.3, we get 0.7. The opposite, B given A, you put the A down now instead of the B, then you intersect A intersection B. So since we found our A intersection B as 0.2 and our A was given as 0.3, we divide 0.2 over 0.3, we get 0.67. All right, so I want somebody to try just on these that I've done. Suppose we're actually given question number 2 that I gave you. We're given a probability of A as 0.4, probability of B 0. Probability of B 0.3. Probability of A given B, it is 0.4. Somebody help us find the intersection. So intersection, complement, reciprocal of this, which is B given A. I I want in that order, and the union set. Each one to choose one. Pick the easier one before it's gone. So find the intersection of A and B, the union of A and B, and the complement of A, the complement of B, and B given A in that order. So each one to pick, wants to pick on A, wants to pick on B. We're about 5 or 6 there. Each one to pick one. Robbie, which one are you picking? These classes must be interactive.
I think let everyone pick. I'll pick the last one. I can even pick the first one.
Okay. Esther.
Okay, let me pick the first one.
Okay. So lead us through the first one. What do we do? Yes. We're looking at how do you find
Yes, the challenge is where I am. I'm using a phone. Power is not there. So I was trying to again use the phone.
no, just tell us what to do. So what do we do here? What's the first thing we do? We
Okay,
expand.
Yes, we expand that.
What does it become?
We say the probability of A intersection B
Over what?
over B.
Over B. Is it right? Is it over B or over A? It's over B. This one must always come there. Next, so whenever I give a conditional probability, you see something like that. The first thing is you expand it. All right. Then next, what do we do? We substitute what has been given. So continue.
Yes. So what we've been given is A given B is 0.4. Should be equal to P probability of A intersection B over the B is 0.4.
The B is what?
The probability of B is 0.3.
So in first multiply.
Okay, so when we cross multiply, that will give us 0.12.
As our A intersection, what?
So probability of A intersection B will be equal to 0.12
Because you multiply 0.4 times what?
by 0.3.
Okay, great. Next, who's going to pick A union B? Somebody else to pick A union B? Agatha. A union B, what do we do? What's the formula first of all? Agatha and Esther. Chestnut. What's the formula for A union B?
was a bit late, but I think it's the probability of A plus the probability of B minus probability of A intersection B.
So what do we have? What do we already have from that formula?
We have the probability of A, which is 0.5, and the probability of B, which is 0.3. And we're just from finding the probability of A intersection B.
Excellent.
So 0.5 plus 0.3 gives us 0.8. Then when we subtract 0.12, we get 0.68.
Excellent. Okay. Next, somebody to give us a complement of A. That one has to give us a complement of B. The complement of A, the complement of B. Nisa, how do you find the complement of A? Beth, how do you find the complement of B? Gloria, how do we find the complement of A?
I just joined just now, so I'm just catching up.
Robbie, help out.
Hello?
How do we find the complement of A? The complement is
The complement of A will be 1
minus P.
PA.
What? P.
PA.
Probability of A.
Good. So the complement is the opposite, right? If A is 20%, the opposite to get 1 is what? 8. So what is our A? 0.5. So 0.5 from 1, we get 0.5. So what then is the complement of B? What is the complement? Somebody else?
Complement of B is 0.7. Oh,
How do you get the complement of B? It's 1. The complement is 1 minus itself. So for B, it's 1 minus what? The probability of B. So what is the probability of B?
3.
3, yes. So 1 minus 3 is what? 1 minus 0.3. How do we get? 0.7.
7.
Good. Then what is B given A? How do we expand B given A? Which one goes down? Which probability goes down?
A.
A.
Then on top, what we have?
Probability of A intersection B,
Section B.
which
So,
we already have.
which we already have. Do we have A intersection B? Okay. 0 point what? 1.
0.5.
And what's the probability of A?
0.5.
0.5. And what do we get?
0.24.
24. Great.
Sorry. Hey, so I have a question. On this one, so for the top part where it's P A intersection B. It doesn't change since it was P B over A. It won't be B intersection A.
It's the
It
same.
still
Like I
stays the
said,
same.
it's like 2 times 3
The
and
same
2
thing.
times 3. It's the same thing. A intersection B
Okay.
is the same as B intersection A.
So it doesn't matter if you put it either way.
It doesn't matter, yeah. That's why I
Okay.
say most partitions love starting with the letter which comes first in the alphabet.
Okay.
So I also mentioned something important to say if you're intersecting probability of A intersection B complement plus the probability of A intersection B. When I add these two, what probability do I get? Common letter, which letter is common?
A.
A, yes. If I had probability of D intersection A plus probability of D intersection B, what do I get as a total probability? What do I get? Common letter is what?
D.
Probability of
Exactly. Now, if you're given probability of A given B complement as 0.2, and we're given the probability of A as 0.3, and we're given the probability of B as 0.4. Okay, so let's expand the conditional probability we are given. How do we expand this probability we are given? Somebody try. A, we're being asked to find the probability of A intersection B complement. Okay, so let us expand this. What is the probability of A given B complement? What goes down? What comes here? What comes here down? B complement. And what goes on top? The two letters as they are. We have A, and we have what? The B complement. Don't alter anything. The same format that follows. Anyone lost so far on the expansion? So this one goes down as it is. Then these two letters, you put them as they are. So what is A given B complement? We're given as 0.2. What is
Does
A?
our answer change if we find B complement first?
Yes, that's a good. What is B complement?
It's going to be 0.6.
0.6, good. How did she get 0.6?
one minus the probability itself.
Yes. So the mistake people would make, they don't understand the question, they put 0.4 there. You subtract 0.4 from 1 to get 0.6. All right? And when you cross multiply,
Yeah.
we're going to have A intersection B complement will be what? 0.12. All right. So I'll straight away go to question 1 of the assignment questions. Of course, I'll need you to do that, but I want to give you an idea based of what we've done. All right.
Is this being recorded? Because my phone might go off anytime.
Being recorded. So I want you to try this one on your own, but let me guide you. Of course, the solutions are already. I need you to try. So we're going to help each other, guide each other here. So this will be your homework. Your assignments will be your homework. You need to try them on your own. Okay. So we're
Okay.
given this question here. Consider an insurer that offers two policies. There's a home and there's a car insurance. So we're told that 87% of all customers have home insurance policy and 96% of all customers have a car insurance. Everyone at least has one of the two policies. Calculate the random probability that the selected customer does not have a car insurance. So from what we've learned, let's do bit by bit. There are two insurances. There's home and what? There's car. So we can say home insurance and probability of what? What letter can we choose? H. Car insurance, what letter can we use?
Let's go with H.
C.
C. Okay. Great. What's the probability of home insurance?
Eighteen.
0.87.
0.87. Correct. Then what is the probability of car?
0.96.
0.96.
96.
Nine.
Correct. Then we are told that every customer has at least what? One. So when we add the probability of A, to add is to unite, right? Remember I said probability of H,
Okay.
3 given at least 1, so it's equal to 1. Okay, so the word O means unite or addition. The word and means what? Multiplying or intersection. The word and means what? Intersection or what? Multiply. Okay. The word O means to unite or to add. This is very important. So question 1, what is question 1 asking for?
Calculate the probability that a random does
What
not
is the probability that a customer does not have a car insurance? So it's asking you for what? The complement of which letter?
Is it C or
Of C.
C?
Good, C complement. So
Mhm.
it doesn't come that easy. You need to arrange your data properly. And what is the formula for C complement? It is 1 minus what?
1 minus
Itself with the
Itself.
complement.
All right.
Mhm.
Then part B, what is the probability that he has a car insurance and home insurance? So what are they asking for?
is it in
C
what has an
intersection
so
what?
it's the intersection.
H, right? C intersection H. We know that A, C intersection. So here, when we're going to subtract with the 1 minus 0.96, what do we get?
Zero point zero four.
0.04, correct. So how do we expand the union set of C union H? C union H, how do we expand this? A bit of C plus what?
Plus H.
Plus a bit of H minus what?
The intersection.
Minus
Probability of the intersection.
Minus C intersection.
So we know that the union set we've been given as what? What is the union set? We're told that all of them at least have what? One policy. So where there is the union set, we're going to put what? 1.
One.
For a bit of C, 0. What?
0.9.
And the H,
0.
we are looking for what? The intersection, right?
Yes. Not subject of the formula.
So subject here, when this one comes this side, it will do what? It will be a positive. Then this side we're going to add what? These two and subtract 1. So 0.96
Sorry.
plus what? 0.87 minus what? One. What are we getting?
0.8.
0.83.
0.83. Correct. So far, any questions?
I think it is bad.
Anyone lost so far? This is everything. We're just from discussing all the concepts, right? Part C, can somebody give us a narration? What is part C asking for? Part C asking for? I know you have the answer. I need confidence, okay? Esther, let's not. I taught your uncle some, is it 5 years ago? So he told me to be hard on you. You need to pass this course. So I'll need to be on you so much. Yes, that's not. Has home given car. So H given what? Given is a slash. H given car.
Oh, it's given. C.
Mm-hmm.
So what goes down?
Okay. It's coming back.
The
So
probability
what am I
of
putting down there?
So continue.
Then on top, what we have?
the probability of that intersection C.
Okay. So what is our H intersection C? It's the same as C intersection H, like I say that. 3. Then probability 2.96. So what do we get?
Hey, sorry, can just Tabitha and to just mute their mics for a bit so that there's less background noise.
Okay, so the question was asking us to find the probability that has insurance given that he has a car insurance, home insurance given that, so H given that C. So our H intersection C over probability of C. So here we found C intersection H. I said intersection is the same as multiplying. So in this case, our H intersection C is 0.83, our probability of C is 0.96. So when you divide these two, you get H given C. What are we getting? What's the answer we're getting?
0.6, 0.86.
0.86. All right. Then the last one does not have car insurance given he has home insurance. What narration, what notation are they asking us? Does not have car insurance given that he has home insurance. Yes, not. How do we put that narration? Okay, so the last part was asking us to find probability that what does not have car insurance given that he has a home insurance. So what we are going to do is simply to find probability does not have car insurance, so C complement, given that he has home insurance, given H. So how do we expand this? What goes down? Probability of H. And on top, what are we going to have? Probability of C complement, intersection what? Intersection H. So that is what you're supposed to do.